just the before, unset or reset it, or just keep this. Okay? And main exit. And now is the first thing it does. Check your contact resistance from electrode 1 and 28. Okay? So that F1 is check your contact resistance. It will check every pair of electrodes. 1 and 2, 2 and 3, 3 and 4. Since we have here this insulation box, which is the 60 ohm, everything there is resistance inside 60 ohm. So everything is safe. And just push any key and just go out from there. And I'm out, so I can just start measuring. So start measuring. So loading the command file and then start measuring. So on the right side at the top, it will show you how long it will take to measure. 18 seconds. And that's 18 minutes. Yeah. On the left side, you will see every voltage. On the middle, you will see current resistance. Okay? On the right, you can see command line. 2 of 117. So we're on the 7th command line now. So current injection between AS3 and AS2. And then whether it's showing 12, that exactly is the measured position is 4 at this moment.
So what is going to be update?
Okay, this is the, it's not showing correctly here in the simulation. Just wrote it down. It's about 25 milliamp should be. So this is how you do for a whole field. Then any key you press, you just stop. Okay, this is how we do today. Okay, is there any question? If it is not, you will go outside. You will go outside, start doing this. We will do 1D, 2D, and 3D. Current cable, another current cable.
But I would just want to show you what you need to do in the field, how you can make it good measurement, that's all. So this is the base with the 4 electrodes, but it is same to multi-electrode. So let's start with 4 electrodes. And first thing you need to know in the vertical sounding, where will be your location. So your location will be in the right here. But in the middle, generally, what you put is wooden stake, not a metal stake. Okay, we don't have wooden stake here. So you just put wooden stake, and you tied up your cable, comes the instrument. You tied up another cable, comes the instrument. This is how where you put your voltage cable rails in the middle. The reason you tied up, when you pull, you don't want to pull everything, okay? The other thing is the current cable, you don't have to tie it up the same place. Current cable comes separately. It's better always not touching each other. It doesn't happen with our system, but if you have a different system, it makes crosstalk between the cable, voltage and current, make noise on your measurement. So it is better to use it separately. So it is better to use it separately from the back, like going this way, okay? So you don't want to go all the way here. Okay, when you put in the wooden stake in the middle, what you do is generally either your cable has a mark, your cable has a mark of meters, or just color tapes. So because what you're doing in vertical sounding, you're using always, let's say, Schlumberger, you're using always same configuration. You don't change it. So you use like a 3 meters mark on the yellow cable, like a 1.5, 1.5. And then what is next is, let's say, 4 or 5. 5 meter mark, 8 meter mark, 12 meter mark. There is always a mark. When you come double up measurement, you have 2 marks. So when we double up measurement, when our voltage electrodes, voltage measurements, we need to expand Mn, then we need to stay AB over 2, same position, change Mn, measure. So with this double up the measurement. In that case, you put your yellow cable, double up locations. And that means you need to now repeat the measurement. So that's how you do that. So if you don't have any mark, you can easily put 2 measuring tape on both sides.
The stick is just fixed.
No, don't worry.
No, don't do that.
Oh, no, it's not. Get that one high.
Okay, just give me just pull. Yeah, just pull it both sides. Just pull both sides. Pull. Just go straight. Both of them has to go straight.
You way.
Go. But make sure that. Say, just open up a little bit here. Please open up a little bit. We can see. Oh, it's okay. We can see we're on the straight line. Okay? Yeah. We're okay straight now, more or less. So how you set up your positioning of the vertical sounding measurement? So from this point, you need to put your electrodes. Since we don't have, we have extras here. So since we start like a 0.25, right? What they said, I obey. I don't do different things. So 125. This is their feet. 125. So other is, what we have is 1.5, right? 150. Yeah, that's just one. Yeah. Okay, so here is easy with hand, but in the field, you need to hammer up. Make sure that you have a good contact in the ground. So when you look at it like this, touching it, it's tightly is in the ground. But if it is loose like this, so this creates noise. What happened if I just do here? Since some movements, some hardness is not sufficient enough, the current, it doesn't go well through because of contact resistance changing. If the contact resistance changing during the current injections, it gives error on the measurements. So you want to make sure this tied up securely, everything. Okay, we're done with this. The next step is to connect our rails to stainless steel electrodes. I think this is a little high. So I don't want this to here giving to me trouble, so I just want to remove it. Okay, let's just connect directly to each of them. Yeah, just connect the generally black is for the, it doesn't matter, but just for decoration.
It should be
This big reels has a brake also. If you get loose, and you can just put a brake, it doesn't turn itself, and then screw up the cable. Yeah. So these manual cables,
Yes.
what we use is called American Standard 18 AWG, which is about 1.2 millimeters copper cables. It has lots of the copper turn inside, and then it's galvanized outside of the copper. Then it doesn't oxidate. So it is, you can pull, but make sure that it's not scratching to outside in the field. What happens is if you make scratch on this, next time when you use, if it is in the ground, the scratch part touch the ground, it also injects current from there. So I assume I am injecting that, but also from here. So that will create multiple current injection points. So that creates also the noise. So you want to make sure that we're injecting exactly there. So this is a B, M, N. So let's just connect it. So we need the power cable. So I said earlier you can power up the instrument with one battery or two batteries. When you use one battery, it's 100 watt power output. Two battery is like a 200 watt power output. It is a polarities, but it doesn't really matter with our system. If you change polarity, it doesn't turn on. So you have to put plus is plus, minus is minus. So it doesn't burn nothing, but it doesn't turn on. So once you're done, just turn on. So I will then make one measurement, couple measurement, then everybody can come to same technique itself. So just what we did inside, exactly I will be doing. Manual mode. Schlumberger create data file is, let's call this Schlumberger sounding one, okay, like this Schlumberger F11, F2H, 1, Schlumberger 1, okay? Meter, and AB over 2 is, we have here, AB over 2 is 1 meter. So MN over 2 is 25 millimeters. And then just measure. But you want to make sure first contact resistance is okay. So he's already doing, is showing resistance is 19 milliohms, and standard deviation 5.9 is noisy, and cycle is 2, current is 6.6 milliamp, and apparent resistive is 1000 ohm meter. Okay, I will just go to 644 default setting, alright, and then just go 2 and measure one more time. Oops, I have to change it. AB over 2 is 1 meter, MN over 2 is 25.25, and then just measure. Okay, now it's okay. I just, first measurement was too much standard deviation, more than 2% measuring error. I just put it in the default setting that permits to, instead of I think inside what we were using is 25 milliamp, and I just put it to 2000 milliamp. It reduced this to about 20 seconds milliamp current injection for this position. So it automatically reduced the optimum current for this configuration. So whatever configuration is, it checks contact resistance, and depending on the measuring distance, and then it says, okay, I can do it over here, this much of current injections. And it automatically also adjusts all these amplifications and to get an optimum voltage reading. So you don't have to do nothing to reduce either voltages or current or let's say the output or input voltages. You don't have to regulate nothing. So it does everything automatically. Standard deviation should be less than 2% always. So anything you do is, because what we are doing is repeating. So we repeat the same point, we get 2 reading. So if it's perfect condition, 2 reading will be same. So like what I'm getting here is standard deviation 0%. So that means this 2 reading is exactly the same.
So please, if after changing the settings to default settings, if the standard deviation is still
about 6%.
Is still more than 5%.
Yeah.
And taking a lot of readings, you still get the standard deviation to be high. What do we do?
Well, just go to default setting. But if you don't do default setting, and I can just go arrange all setting myself. So I can check the current. How much was the current before? Like I think is for testing other day, I reduced this 15 or 25 milliamp. So now we increase this to 2000. So that automatically instrument is reduced later on, what optimally can be injectable there. But you can go to measuring setting, you can check each parameters. And generally you can check your geometry, you can check measuring parameters, and then you're done. So